We're going to look today at solving linear equations. So first let's look at this example. We have x plus 3 is equal to 5. Now what we learned before is that this equal sign means that both of these expressions are equal to each other. That means they have the same value. Some of you could look at this and say, oh, the answer has to be 2. But we could also think about that we want to keep our equation balanced. And so we have these properties that allow us to rewrite this equation as equivalent equations. And so what we can do is try and isolate our x value. And so to do that, I want to undo this adding 3. So I know that in order to figure out what the x is, they took the number x, added 3 to it, and then got our 5. So we just want to undo that. So to undo that, we will subtract 3 from the 5. But if I subtract 3 from the 5, I also have to subtract from the left side of the equation in order to maintain balance. So just for example, if you have like 6 equal to 6, those are numbers that we know are for sure equal to each other. If I want to subtract 2 from the 6, the first 6, and I don't subtract it from the right side, I no longer have an equation. I actually have an inequality. I have 4 is actually less than 6. But in order to maintain equality, I have to subtract the same thing from both sides. Or I could do other operations too, like add the same thing to both sides, or divide the same thing from both sides, and so on. So there's this balance idea. So if I have 6 equal to 6, if I subtract 2 from the left side of the equation, I have to subtract 2 from the right side. So that way I get a 4 on the left and I get 4 on the right. It's still maintaining that balance. So if I go back to the equation I started with, when I look at this whole entire left side, if I have a negative 3 or subtract 3 and a positive 3, that leaves me just x by itself on the left side. On the right side, subtracting the 3, I get a 2. So we have x is equal to 2, which is what we thought, but kind of guessing. Now if we can look at a little bit more complicated equation, we have 2x plus 7 is equal to 11. So what this says is that 2 times some number that we're going to try and figure out, add 7 to that, gives us 11. So again, we want to undo the operations that occurred, and we want to maintain the balance. So sometimes I have to draw a line to separate both sides of my equation. And as I go to undo things, I'm going to subtract the 7 first. It's like you're undoing order of operations. Order of operations, remember, says to do your multiplication, then you add. So if we want to undo that, we'll subtract, leaving us with just 2x. And then we undo the multiplication by dividing. So we'll divide by 2. And again, you're doing this on both sides of the equation to maintain that balance. So we're left with x is equal to 2 again. Now this one wasn't so obvious that the answer would be 2, and it's just a coincidence. But if I want to make sure that my answer is correct, all I need to do is plug it back into the original. So when I plug back into my original equation, I have 2 times 2 plus 7 is supposed to equal 2, but we're not sure just yet, 11. When we do our order of operations, we get 4 plus 7, which is for sure 11. It checks out. Now we can continue to complicate these equations a little bit more, adding a few more terms here and there. The idea the entire time is that you still want to maintain balance. Whatever you do to one side, you do the other side of the equation. Sometimes though, you'll have a case where you have variables on 2 sides. So in order to make it look more familiar, like the equation above, we want to try and put our x's all on one side. And so we could take this term, this 3x, and move it to the other side. Well, to move it means just make it go away from this side. So there's a positive 3x. If I take away 3x, that just becomes 0. But if I do it on that right side, remember, maintaining balance, we have to subtract that 3. So we get 3x plus 19 is equal to negative 8. And then it looks like just above. So to isolate x, we will move the positive 19 over by subtracting 19. Make 0, subtract 19. We're left with just 3x is equal to negative 27. Divide each side by 3. We get x is equal to negative 9, which you could check if you'd like. We're going to look today at solving each side. You have an expression, and in order to simplify expressions, you can do that if you have any like terms. So let's look at the left side first. I notice I have 13x here. That can combine with negative 9x. 13 and negative 9x gets me 4x, and that negative 43 still sits there. So that's as simplified as we can get because we have an x here. On the right side, we have 6x that can combine with 5x to get us 11x. We also have 37 and negative 66, which will get us negative 29. So we want to make sure that you simplify each side first. Then you can try and put all your x's on one side. So when I look at this, I can move either the 4x or the 11x to try and be with each other on one side. Often I'll take away the smaller value to try and maintain positive numbers, but it doesn't really matter. Right now I'll subtract 4x, so that gets me 0. I have negative 43 is equal to 7x minus 29. So in order to get this x alone, I will add 29 to both sides of my equation, which leaves me with negative 14 is equal to 7x. Last, I will divide by that 7. And again, the reason why I'm dividing is I'm undoing that multiplication. You can see that 7 divided by 7 is 1, which leaves us with x by itself. On the left, we have negative 2. This next equation looks slightly different because we have some parentheses thrown in there. Now, if we have parentheses and you see a number in the front of them, that should make you think of the distributive property. Because first maybe you're drawn to the parentheses, but there's nothing you can do inside those. They can't be simplified because they're not like terms. So when I see this little number out front and no operation in between, it means multiply. So I'm actually going to distribute it to each piece, which when I distribute, it becomes 6 times 3x, which is 18x, and 6 times negative 8, which is negative 48. Now I still have this plus 14. It falls down here. On the right side, I again have a parenthesis, and there's a 3 right in front of it, so I will distribute that. Now x just falls right down here. We distribute the 3, we're going to end up with 15. And 3 times negative x is going to be a negative 3x, and then the 1 still falls down. So then we want to try and just continue simplifying each side. When I look at the left side, 18x doesn't have anywhere else to go with. Then I have negative 48 plus 14, which gets me a negative 34. On the right side, I have a few terms that can go together. An x with a negative 3x is negative 2x. 15 and 1, that gets me 16. Now at this point I have variables on each side of the equation, but individually each expression is simplified. So now I want to try and put my variables all together. Again, I like to try and maintain positive values. You don't have to, but it's nice. So I'm going to put plus 2x. That makes that become a 0. If I do it on the right side, I have to do it on the left side. That gets me 20x, subtract 34, is equal to 16. Now I still need to isolate x, so first I'll undo that subtraction by adding. That leaves me with 20x is equal to 50. To isolate x again, we're going to divide by 20 to make that 20 go away. Again, you're undoing that multiplication. So we'll divide both sides by 20. That gets us x is equal to 50 over 20.